All right, guys. All right, so here is our plan today. We are going to take everything you've done with position, velocity, and acceleration, and we're just going to switch gears into looking at graphs. But if you understood everything we did on the position, velocity, and acceleration topics, today should be pretty easy, okay? So let's take a look at your first graph. The first page is a position graph. So if you have a position graph, all of the y values are positions. Okay, why are the y values positioned? Because it's a position graph. The slope of a position graph will give you velocity. And the reason why is because remember, a derivative on a graph is a slope. So if the derivative of position is velocity, then the slope of this graph will be velocity. Okay, what about the second derivative? What does that tell me? Concavity will tell me acceleration. Very good. So think about as you're taking the derivative, position goes to velocity, goes to acceleration. On the graph, y values go to slope, go to concavity. So let's answer some questions, see if you kind of get the idea. So this is a position graph. Okay, it says it's moving along the x-axis. Sorry that I kind of put the graph in the middle of the sentence. Okay, but then it says given by the graph shown above. The particle is on the right side of the origin on the interval blank. So if I want the particle to be on the right side of the origin, what kind of position would it need to have? Positive, very good. So I want you to put right here when position positive. And then remember that position is the y values. So I want my y values to be above the x-axis. So think about if that logic makes sense. This is a position graph. So if I want my particle on the right side of the origin, I need this graph to be above the x-axis. What interval does that happen on? 1 till 10. Very good. Okay, what's that? Oh, the packet. Okay, then I forgot to put on there the left-hand side, but if you want to write it in, you can. Sorry, I know I printed it and put it somewhere special, but I forgot where it is. You're welcome. Okay, so particle traveling to the right. What tells me the direction the particle is traveling? Is it position, velocity, or acceleration? Velocity. And if I want my particle to be traveling to the right, what do I want velocity to be? Positive or negative? Positive. And remember, what's velocity on this graph? Slope. So let's come down here. When velocity is positive, then the slope needs to be positive. So looking at this graph, my slope will be positive whenever it's uphill. What interval does that happen on? When is my graph uphill? 0, uphill, 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 all the way till 7 is correct. Now, someone in the other class had said, well, technically at 4, it kind of like goes flat. Since it's increasing and then keeps increasing, you do not have to break this into 2 separate pieces. You can just go straight through. So this would be considered increasing all the way from 0 to 7. Okay. Now, my particle will be traveling to the left anywhere that my velocity is negative. And remember that velocity in this case is the slope of this graph. So when is my slope negative? Starting when? 7, and then all the way to the end of the graph would be 18. Okay, next we want positive acceleration. Acceleration, look back up here at the top. Acceleration is the second derivative, which is the concavity. Now, because it's kind of hard to tell where the bends in the graph happen for concavity, they're going to give you those little dots to sort of break it down. So everywhere that you see this circle on your delta math, that means the concavity changes. Okay, so I want the acceleration to be positive. That means the graph I'm looking at needs to be concave up. For this verse section, is it concave up or down? Down. And I want it to be what? Concave up. So I don't want that one. What about here? So 4 to 6. Union. Okay, then my next chunk between these two bubbles is concave down. I don't want that. But then for my next section here, it's concave up between what interval? Okay, 9 to 12. And then for my last section here, between these two bubbles, I can see it's back to concave down. I don't want that one. Okay, then it says when graph is concave down. And I'm gonna, sorry, I meant concave up. I'm gonna abbreviate that CCU, concave up. Now, if I want a negative acceleration, then I want a negative second derivative, which means I want concave down. Okay, that would be basically the missing pieces of the intervals I haven't listed. So 0 to 4, union 6 to 9, and then my last part here from 12 to 18. And that would be when this graph is concave down. Okay. Last new thing we added last time was we talked about speed. Remember that a particle is speeding up when velocity and acceleration have the same sign. But now we need to think about what features represent velocity and acceleration on a position graph. So velocity is the what? Slope. And what is acceleration? Concavity. So if I want the concavity and the slope to have the same sign, then here are your two choices. You could have a positive slope and be concave up, or you could have a negative slope and be concave down. Okay, but that would be the only way for your speed to be increasing is if it's a positive slope, positive concavity, or negative slope, negative concavity. So once you have that written down, look back at your graph. Between the first two bubbles, so that's here to here, what's my concavity, up or down? Down. Is there any section where the slope is also downhill? Yes or no? No. Okay, now let's go between here. Is it concave up or concave down? Up. Is this slope also up? Yes, so list that. It would be between 4 and 6. Okay, write that down. 4 to 6. Okay, next two bubbles are here to here. Concave up or concave down? Down. Where is my slope also down? Not the whole time. From 7 till 9. Very good. So let me catch up to y'all. We said 0 to 4 was a no. 4 to 6. And then 7 to 9. Okay, our next little bubble would be from here to here. What's the concavity, up or down? Up. It's up like a cup. Is the slope also up? No. No. And then on this one, I'm concave down. Is the slope also down? Yeah, so we would want from 12 to 18. So in order for in order for velocity and acceleration to be the same sign, you would need slope and concavity to have the same sign. Does that make sense? Okay. Half of your homework is position graphs. The other half is velocity graphs. So turn the page, please. And now your graph isn't position, it's velocity. So if you're looking at a velocity graph, the y values will be velocity. And then if you take the slope of the velocity graph, that would be acceleration. Now, if I take the second derivative and I look at concavity, I want you to think about this for a second. Concavity would be the second derivative of velocity. Okay, but what would that be to position? Third derivative. Okay, and so I want you to think about, if I take the second derivative of velocity, that's the third derivative of position, and you don't have a thing for that. So you don't need to know concavity on this graph. You would only care about velocity, which are the y values, acceleration, which is the slope. Okay, what else is missing from this graph? Position. And remember, when you take the derivative, you lose a little bit of information. So this graph cannot give you position. Okay, when you take a derivative, you lose a little bit of information to where when I'm looking at my velocity graph, it can no longer tell me anything about position. Okay, so let's look at our velocity graph. First question is, when is the particle traveling to the right? So the particle will be traveling to the right when the velocity is positive. When velocity is greater than 0. And now remember, this is a graph of velocity. So I want my y values to be above the x-axis. So looking on your graph, what sections are above the x-axis? 0 to 1. 0 to 1, 8 to 12. And then one more. 17 to 18. So 0 to 1, 8 to 12, and 17 to 18. My particle will be traveling to the left when my velocity is negative. But remember, this is a graph of velocity. So I would need my y values to be below the x-axis. Where are my y values below? On what intervals? Okay, 1 to 8, union. 12 to 17. Okay, and then I forgot to put this on here, but my particle will be at rest. I'm going to just write it on the graph. Okay, the particle will be at rest anywhere that the velocity is 0. But remember, this is a graph of velocity. So my velocity will equal 0 whenever I hit the x-axis. So looking at your graph, when is it going to be at rest? 1, 8, 12, and 17 is correct. Because that's where my velocity or y values cross 0. Okay, from there, you can determine whether each one of these is a min, a max, or neither, based on the direction that it passes through the x-axis. So here's what I mean by that. At 1, before 1, was that above or below? Above is positive. And then after 1, what is it? Below. So my velocity went from positive to negative. That means I went from going up to down. Is that a max or a min? Max. Okay, now let's go to 8. Before 8, I was below. That means negative. And then after 8, I cross into the positives. That means that my particle's direction was down, then up. Is that a max or a min? Min. Okay, so do the next two. For 12, will it be a max or a min? Max. And then for 17, max or min? Min. So you're looking for the direction that it passes through the x-axis to determine max or min. Okay, let's fill in our blanks down here. We're going to have a relative max at t equals 1 and 12 because velocity changes from the positives to the negatives. Okay, write that down, see if that makes sense. Velocity changes from positive to negative makes it a max. Where did my mins occur? What numbers? 8 and 17. And how did my velocity change? Negative to positive. Okay, and remember, this is how you find relative mins and maxes on any graph. This just happens to be a position velocity acceleration. Okay, next question. We want a positive acceleration, but remember, this is already a velocity graph. So if this is velocity, acceleration is what feature on this graph? Slope. So look at your graph. I want a positive acceleration, then I want a positive slope. And then looking on your graph, what is the first section of your graph that has a positive slope? From where to where?
5 to 10.
Okay, 5 to 10 and
13 to
13 to 18. Very good. So 5 to 10 and 13 to 18. Okay, I'm going to have a negative acceleration anywhere that this graph has a negative slope. So that would be from 0 to 5. And then 10 to 13. Because we have a negative slope. And remember, on the velocity graph, acceleration is the slope. On a position graph, though, you'd look at concavity. All right, last little bit of this. Let's talk about speed. Speed is increasing when velocity and acceleration have the same sign. What feature is velocity on a velocity graph? Okay, look back at the top. What is velocity on a velocity graph? It's the y values. And what feature is acceleration? Slope. So I need the y values and the slope to have the same sign. So here are your possible combinations. If you're going to have a positive y value, you would be above the x-axis. And you would need a positive slope to go with it. So a positive y value and a positive slope, that would be a speeding up. The other option would be below the x-axis and a negative slope. So look at your graph. When it is above the x-axis, what is the section where it also has a positive slope? There are two spaces.
8 to 10.
8 to 10 is the first one.
17 to 10.
And 17 to 18. Okay, both of those intervals, you're above the x-axis and you have a positive slope. Remember, though, you're also speeding up when you're below with a negative slope. So look back at your graph. When I'm under the x-axis, when do I also have a downhill slope?
1 to 5.
1 to 5 is correct. And then one more section,
12 to 13.
12 to 13. Okay, conversely, the speed is going to be decreasing when you have the opposite combination. So for a decreasing, you would need the y values and the slope to be opposite signs. So your possible combinations would be above the x-axis and a negative slope, or below the x-axis and a positive slope. But you would need them to be opposites for slowing down or speed decreasing. So when are you above the x-axis with a negative slope? What sections? There should be two. 0 to 1. And then where's the other one? 10 to 12. Okay, not only can I be above and downhill, but I could be below and uphill. So where are the sections of the graph where you're below and uphill? 5 to 8
13%.
and 13 to 17. Very good. Make sense? Okay. Go ahead and turn the page. I'm going to have you kind of try the next one, except for I don't want you to do E and F in the middle. We'll do those parts together. So E and F here, I want you to just skip those for right now. Okay, but all the rest of it you should be able to do. Should you do it like number 1 where you had a position graph, or number 2 where you had a velocity graph? Okay, read the little thing. What type of graph is this? Velocity graph, so make sure you're looking at example 2, not example 1. Your homework though will flip-flop back and forth.
The rest whenever it goes to the x-axis. Yeah.
All right. So if you want it to be at rest, what are y'all looking for? Okay, good. Where does it hit 0? 1, 5, and then really that last interval, since it sits on the x-axis, you would put 8 to 10. So you would do t equals 1 and 5, and then you also have this little section here. Do you see what I'm saying? So it'd be 1, 5, and 8 to 10.
I've never done that.
That's what it's about the when I talk about. Yeah. You're the one. Yeah, but it's awesome. I think it's.
That section sits on it. For that.
Yeah, I guess it's just.
How y'all doing?
It's great.
Okay, so where is it gonna be at rest? What do you think?
It's going down.
If t equals 0, which means it needs to be on the x-axis. I put an and in the middle, so it's t equals 1, 5, and from 8 to 10. It would be 8 till 10, because see how it sits on the x-axis? So if you look right there on how I wrote it, basically the 1 and the 5 are like individual numbers, and then 8 to 10 would be like.
And opposite. The minimum.
Yeah. Yes.
Oh, isn't it? It's where it hits the x-axis.
Is there another section? Oh. What would you put for your decimal? Yes. So they should be labeling them.
Yeah, I think it's eight. We can do the other after. That's just for this.
So since you're on the y-axis, traveling up would be positive and down would be negative. So up would be the same as to the right, and down would be the same
And
as
that's,
to the left.
that's where it's.
Yes.
That's one of the party, 0 to 3. Or 0 to 3.
One is, how did you get?
Locked in. I'm like.
Okay, so think about it,
What do you
it's
have?
from a positive to a negative.
What I don't see that.
Because if it goes, because it,
Wait, it's 6 and then.
well, not eight, so you want five, because you want the x-axis one.
For the Minimax.
Put it in max. So for one, it's a max, because it goes from plus to minus,
Okay,
and
so
then
that's
draw
where-
with your finger, up, little down, and then for five, it goes to negative. Negative to positive, which down. Now, eight, since it doesn't actually, that doesn't count anymore.
So it'd be like 1
Okay.
to 2.
Good job.
That'd be negative. Yeah, but it's, but if they're both decreasing, then it's speed. And then 5 to 6.
You can go past it, like, go down.
Speed, 3 to 5. Right, the acceleration is outside. Yes, so on this graph, if we only made a velocity graph, that's where you. Can-
So when would it be traveling up of dollar? What would you need velocity to be?
Above. See, they're above the graph.
0 to 1, and here's why, because remember, this is velocity, and you need it to be above graph.
That's fine. But like-
Uh-huh, very good. Okay, then what would you put for your justify? So 0 to 1 and 5 to 8. Don't call it DBDT. Oh, well, you could, I guess. No, that actually is right. Wait, no, not DBDT though, it would be, I would just put VFT for velocity. And then instead of is positive, just put greater. Yes, sir.
So on this example, it says.
You'll always be on the X and Y axis.
It's on the left.
One, it tells you that your particles are traveling exactly that way, right? Versus on this one, it tells you your particles on the Y axis, but you work in the same way that right and up, right? Positive, down and left.
Okay, I just didn't notice.
I'll do it, okay?
Actually go back.
I'll do it, okay? Okay, so what's your traveling down?
Oh, you're right, bro.
1 to 5, okay, good. And then min and maxes, were you, oh, we already did.
Yeah, it's also 6 to 8.
So put 1 is max, E cut. E if T changes.
First name, name. We put at the DV office. Because they're not laughing. We did it.
You did the whole thing, except the ones we skipped?
They did all by itself.
Good job.
Oh, can you reset, like, hear the questions on home?
Yeah, I'm not gonna do it right now because I don't wanna put your grades on the recording, but, as soon as we're done, remind me.
Alright. I just want to remember that it's not like you're good on the third.
I've done it before, to be honest, so,
It was.
not yours specifically, but I've done it before.
You don't edit the videos?
No, I don't even know how. I edited the videos, to be honest.
My face on there.
Why do you think I use Zoom? Because it's all I know how to video in. All right, check your answers for the first couple. Okay, see if you got it right. Okay, then your acceleration should be positive when this graph is uphill. That only happens from 3 to 6. Your acceleration is negative from 6 to 8. And then when you're looking for speed increasing, do you want same sign or opposite signs? Same, and of what two things? For speed increasing, what do you need to be the same sign? So acceleration and velocity, and what features are those on a velocity graph? Slope and y value, very good. So I'm going to put here the slope and the y values need to be the same sign versus in the second part of that, you're looking for the slope and the y values to be opposite signs. Yes?
Isn't at 0 to 2 isn't also negative for acceleration?
Oh, I didn't see that. Yes, you're right. Thank you. So we would want above with a positive would be from 5 to 6. And then below with a negative would only be from 1 to 2. Is that correct? Okay. And then speed would be decreasing from 0 to 1 because you're above with a negative, and then 3 to 5 because you're below with a positive.
6 to 8.
And then 6 to 8.
I didn't get that either.
Who did? Well, look at Leo. Okay. Let's do the two that we skipped. Okay, V of 0. Okay, look back at part E that we skipped right here. Okay, V of 0, it's asking you to find the velocity at 0. What feature is velocity on a velocity graph? The y value. So the velocity or y value at 0 is what number? 4. Now, velocity tells me the direction of travel. So if the velocity at 0 is positive 4, is it traveling up or down on the axis? Okay, it's traveling up. Okay, but the problem is that it's asking me whether that's towards or away from the origin. The other thing that you have to know is position. And remember that a velocity graph can't tell you position. So read back in the question, read what the last sentence says. Okay, right here it says, the particle is at position -3 at time 0. So I can't get position from this graph, but it tells me it right here in the question. So put y of -3, or I'm sorry, y of 0 is -3. And then I'm going to put given in the problem. Okay, I cannot pull that out of the chart, but if they tell me that, then I can determine where is my particle. Is it above or below the origin on the y-axis if the position is -3? So if I have a negative position, is it above or below the origin? So it's below the origin, but it's traveling up, then is it going towards or away? Towards this craft. Okay. So if I'm below the origin, because they told me the position, and I'm traveling up, then I know I would be traveling towards. Okay, last thing we're going to add to that is the acceleration at 1 and 4. What feature is acceleration on a velocity graph? Slope, very good. So put A of 1 and then A of 4. Okay, now remember what we said, acceleration is slope. The only way that you can count out the slope of a graph is if it happens to be a straight line. Okay, if you have a straight line all the way back in Algebra 1, you learned that you can count the steepness of the line or the slope using rise over run. So let's go to 1 first. Okay, this would be the slope of the line at 1. So come right here to 1. First question, is it a straight line that I can count the slope by hand? Yes, it is. Then pick 2 pretty points and count the rise over run. So I'm going to pick this one and this one. What is my rise? -4. And then what's my run? 1. So -4 divided by 1, what is my steepness? -4 is correct. So the acceleration at 1 is exactly -4, but you can only count out the slope if it's a perfect straight line. Okay, we're also going to do that at 4 seconds. So come over here to 4 on your graph. And remember, I can only count out the slope if it's linear. Is it linear? Yes. So I'm going to pick 2 pretty points, and then I'm going to count the rise over run. So I'm going to go from this endpoint to, we'll go to 5, 0. How many do I have to go up?
2.
I'm starting from here to here. So that would be rise 4, run how many? 2. And if my rise over run is 4 over 2, what does that divide to? 4 divided by 2 is a slope of 2. Okay, there's one more time that I want you to add acceleration for. Let's find the acceleration at 6. So add in a of 6. Go to your graph at 6. Is that on a line? Okay, you should notice that at 6, what feature is that? It starts with a C. Not a cusp, but it's a corner, which is kind of the same thing. So if you are on a cusp or a corner, you cannot take the slope at that point. Okay, so we'll put cannot find the slope. And the reason why, if you think about it, is that on one side, I would count out a positive slope. But on the other side, my slope is negative. How do I know which one to pick? You can't. So come down here to your a of 6. And we'll put not differentiable. Because corner. Okay. Not differentiable at 6 because there is a corner on the graph and you cannot count out the slope on a corner. Make sense? Okay. You have one more graph to do with your chart and then we're done with notes. So turn the page, next one, give it a shot. Last one.
Okay. That's what's below the
Sydney, what are you doing? It's like 1,000,000 grams of caffeine.
I can stay there. My bad.
No, my mom just makes so bad.
So I would count the rise like that here.
I lost the one. It's going up, and it's increasing. So that would be this 40.
Oh.
Well, hold on.
Minus a lot of that.
Divided by six.
Five, right? Each of them are we?
Well, if your acceleration is positive.
What is that really?
I know my acceleration.
Can you tell them? I'll warm up.
Does that make sense? It's okay, so 0. So at rest means you put on that. 0, 30 is this or that. Yeah, because that's it. So T. Then it says they want the particle to be moving with it. That positive or negative. So you want it to move below the x-axis if you want to. And then for your left side, you put ES, and you actually like. I used to walk. How we do it? We like. Yeah. My dad like constantly brings home like the log. And then for the next one, you want to travel to the right. And then be the be a teacher. It's so good. Yeah. All right, then for your next one, if you want the acceleration of I, what feature is acceleration on?
That one, velocity.
Remember, and then a velocity around, then acceleration.
Velocity is below, I know that, but it's not slope.
Here, this first mark. And you want
The velocity.
it's easier to do from
So like this,
use the endpoint, so you're going like this.
like this.
From here to here,
Can't have this.
what would your rise be? Oh, it's frozen. What would your rise be? How many would we go up from here to here?
Oh, yeah.
60, yeah? So your acceleration at 5 would be 60 over. I'm going up 60 and then over 2 boxes, but they're each 5. Okay. And then 60 divided by 10, what would your acceleration be? Okay, then, if your acceleration is positive 6, does that mean your velocity is increasing? And then remember for speed, if your acceleration is positive, what would also have to be positive for speed to be increasing? So acceleration and what? Velocity, and velocity in this graph would be the y value. So at 5 is your y value also positive. So then your speed would also be increasing. Yeah. Go ahead.
Oh, you're right. I don't know anything about it. I haven't been have a race yet. No, no, Barrett. Just tell the truth. It's okay. No, it's not. Yes, it is. Take out that word. Didn't they have goose? I think you're on a call. Everybody questions what you want.
Okay, were you asking about?
Well, I forgot to do that. I did this. I was gonna ask about this. Would this be where it's flat?
If the acceleration is undefined, you have to be at a corner. And then for it to be zero. Because remember, acceleration is the slope of this graph. So it would be undefined anywhere you're not allowed to count slope at the corner. So 40 and these both count too.
So 10 to 15.
10, comma 15. Because in the middle, 10 to 15, it would be zero. You know what I mean?
Yeah.
Yes, Carter?
Okay, what intervals of time with the velocity?
Okay, so velocity increases whenever acceleration.
How is that?
What's acceleration?
Oh, it's saying right? Oh my God, stop in the middle. Stop. Stop. Last one.
And then
Stop.
where
But like,
velocity
why
and
did you
acceleration is like, which would be your y value.
You know, like, it's not doing this. I'm oh my God.
That would be with velocity.
See, but like, and if you're last, you have to get.
Please shut up.
So you
No, it's not, okay, yeah.
Weird stuff to get the punishment.
Yeah, I know.
Or
You can't close your eyes, you gotta like look around, like.
Or for Leo, probably the good one.
You gotta look around. Okay, you can't know. Bro, you can't like close your eyes, that was fun.
Yeah.
Right. I don't think there's any fun. I'm saying like a challenge, it's like, obviously.
Like,
You've done this before?
Oh. I'm just saying. I think it's pretty cool.
Yeah.
Like, bro, it's- It depends on what area. I don't wanna be first either. Bro, I would be so happy. You know, like, you wouldn't. Oh, I don't care about like the thought of it. I don't think.
So gross.
Wait, are you done? Y'all are all done or just you?
Well,
Almost, okay. Take your time.
I didn't figure out. Yeah.
Okay, so let's do it. So if you want the acceleration at 25, you're gonna find 25 on your timeline. That would put me right here, right? And acceleration is the slope. You can only count out the slope if it's linear. Is it linear? Yes, then pick two pretty points and count the slope between them. So let's say I just want to go from here to here. Then I'd go down how many? Oh, yeah. So I'd have to go down how many? And then over how many?
5.
5. So acceleration at 25 is down 20 over 5. That would be negative. Now, question, if your acceleration is negative, what does that mean velocity is doing? Is it increasing or decreasing? Acceleration is negative, so velocity is decreasing. And then remember, for speed, I have to check and make sure that velocity would have to also be negative, right? So my acceleration is negative. Is my velocity also negative? What feature is velocity on this graph? The y value, which is clearly in the positive. So you would say that the speed is decreasing because they're opposites.
Oh,
Does that make sense?
yeah, I got confused because I thought what you were writing was the answer, and I was like, how could the acceleration be positive? Of course, it would be velocity positive. Yeah.
Okay, but you're good now?
For 48. We go there.
48, you're also on a number line. Or sorry, on a linear section of graph. So you want to remember to count the slope between pretty points. So if I go, let's say from here to here, how many am I going up? And how many am I going over? 40 over 15. Which would reduce, those can both divide by 5. So we okay, then my acceleration was positive. So what is velocity doing? Increasing or decreasing? Hold on, acceleration is positive, so what is velocity doing? Increasing, but what is speed doing? Speed is decreasing, because why?
Because our axis.
Okay, and there being the y value is negative, but the slope is positive. Does that make sense?
Yes, but. So.
Okay.
So A of 48, that's the acceleration.
Uh-huh.
But then why would that mean that the velocity is?
Just wait.
Because it's in our loaded graph.
So remember that an increasing velocity, if your velocity is negative. I don't know if you remember off the notes from last time, but listen to these velocities. Let's say I'm going negative 20 miles per hour, negative 10, negative 15. What are those numbers doing?
That's what they tell you.
No, they're increasing, right? From negative 20 to negative 15, that's an increase.
Because it's a game.
Now, is it also slowing down?
I parked there in and out.
Yes. So that's where you have to be a little bit careful, that if my acceleration is positive, but my velocities are negative, then your speed is decreasing, even though your velocities are increasing.
Yeah.
All right, real quick. Okay, let's finish up just these last couple of new things and then we're done with notes.
I didn't leave the light.
Okay, when is your acceleration 0? Okay, okay, acceleration is going to be 0 anytime that your slope is 0. Where does that happen? What interval? 10 to 15. Okay, and your acceleration is going to be undefined anywhere that you're not allowed to count the slope. When is the slope going to be undefined that I'm not allowed to count it? At what type of thing? Starts the C. Corner, and you have 3 corners on this graph. Where are they? 40. Where else? 10 and 15. These both count as well. Okay, those are still corners because they're where 2 lines meet. So it would be T equals 40, 10, and 15. So it's undefined where you have corners, but a 0 slope would be that little flat segment. Okay, velocity increasing, all you need is a positive acceleration. Where is your acceleration positive? On what 2 intervals? Not 0 to 30. 0 to 10 and 40 to 55. Remember that a positive acceleration means you have an uphill slope. Okay, then speed increasing, you would need the y value and the slope to match. So that would be 0 to 10 and then 30 to 40. Are there any sections I missed? 0 to 10 and 30 to 40. Okay, then speed would be decreasing from 15 to 30. And then also from 40 to 55. Okay, the one that I skipped is that your velocity will be constant when you're not accelerating. So what acceleration would you want for your velocity to stay constant? 0. So this is the same as acceleration 0, which would be from 10 to 15. Okay, and if you think about, if you hit cruise control on your car, your acceleration is 0. Even though you're still moving, your velocity is just constant. So these 2 things are the same. Hopefully you kind of know that. Okay? Before you get out your Chromebooks, the first half of your homework you cannot do today. So let me show you where you're going to start. Okay, listen, you can only do on your homework starting at the graph. Okay, don't do anything above this. Just go from here down. We only did graphs today, not equations. Okay.
So. Because. Like I get it, but I can't explain it. I couldn't write it down. Just doing it.
So,
Let's do a powerlifting workout.
huh?
Let's skip a powerlifting workout. Busy.
What are you busy with? What could be more busy? Wait, that didn't make sense. What could be more important? What club? Oh,
That was only a week.
I know. It really needs to be later in the week.
Just those 2 days. Those were nice.
I know. Hopefully one day soon. Hey, Amelia. Okay, you want to know serving?
Oh.
The only thing is for this next notes, you'll have to have a calculator. So I don't know. I have a Chromebook. Okay, perfect. And I'll post the video on school. Okay, so let's get started on homework, okay?